right, I'm gonna have this up quite a few days now. Let's remember that if I have a hypotenuse of 1 and a 30, 60, 90, my hypotenuse of 1 across from the 30 is gonna be 1/2. Across from the 60, square root of 3/2. We're gonna need this today as we start to work on the unit circle. Hypotenuse of 1. Here, our hypotenuse of 1 on our 45, the leg is gonna be square root of 2/2. And this leg is square root of 2/2. So as we review from yesterday a little bit, I want to start by writing out a nice little Cartesian coordinate system. 1, 2, 3, 1, 2, 3, 1, 2, 3. It'd be -3, of course. 1, 2, 3. This would be negative. I'm going to draw a little circle in there. And we have 4 points that I want to talk about. Those 4 points right there. Make sense? What would be the coordinates of that point right there? My x is what? Now my x is 1. And my y is 0 right here, right? Okay? Now up here, my x is 0 and my y is 1. Right here, my x is -1 and my y is 0. And then down here, my last one, my x is 0 and my y is -1. Okay? What's this length right here gonna be? 1. And in fact, if I put it up there, what's the length up there? Still 1. It's a circle with a length of 1, no matter where I draw a line from that center, right? Okay? Anybody see that movie, Honey, I Shrunk the Kids? It's a pretty old movie, it's kind of funny. Then they had a sequel, Honey, I Did What? Oh, then they blew them up. Okay? So we're gonna take this circle and we're gonna make it bigger. Yeah, he made the kids bigger. He didn't blow them up literally. He blew the kids up. He didn't blow them up with dynamite. He made it bigger. All right, so if that's the case, okay, from yesterday, we had 0 here, 90 degrees here, 270 here, right? Whoops, not 270 there, you knucklehead. That's 180. Got ahead of myself. 270, it doesn't even look like a 2. Let's fix that also on a roll. There we go, and all the way around, of course, was, okay? Then we worked on radian measurement. What's the radian measurement here? Was pi/2, right? This is pi. This is what? 3 pi/2, and all the way around is 2 pi. Okay? Well, today, that is our 90s family, right? We did that yesterday. We're going to add the x and y coordinate. So that's this point right here, this point right here, right here, and right here. Well, we just did it. What is my x here? My x is 1. My y is 0. That's a grid. I just made it bigger, right? Up here, what is it? My x is what? My x is 0. My y is 1. Right? What am I getting over here? My x is what? -1. My y is 0. What am I getting down here? My x is 0. My y is -1. How are we doing? Make sense? Think of it this way, okay? If, by chance, I drew a straight line this way, a straight line up this way, what would this point be? 1, 1. That circle is all within 1 unit. That's why it's 1 unit. Doesn't matter how big, if it's 1 inch or 1 foot or 1 yard or 1 mile, it's 1 unit. That's why this is called the unit circle, okay? All right. Let's do the 45 now. That's the one we did next, right? Yesterday? Okay, remember our reference angle? Straight down, 45. Here we're looking at 135. Here we're looking at 225. And down here we're looking at 315. Now, as you start doing it over and over, you start to come to you. How about radian measurement of 45? If you need to look, it is 5/4. That's great. You guys all say them out, and it'll help you think about it. 135. 5/4. 225. There you go. 5/4, and we finish up down here at 315 at 7/4. I said 7. That was yesterday, right? Well, today we're going to add the x and y coordinate. Follow along with me. All these will be the same except for a little bit of sign. What's the length of that? It's 1. Okay? 45. 45. So if the hypotenuse is 1 of a right triangle with the hypotenuse of 1, what are both sides? We just did it a second ago when we warmed up, right? What is it? Square root of 2/2. Square root of 2/2. Right? Well, what is this distance? That's my x. So my x is square root of 2/2, and my y is also square root of 2/2. Now, up in this quadrant, they're both what? Positive numbers, aren't they? What's it going to be over here? Still going to be the same 1, but now my x here is going to be negative square root of 2/2, and my y is positive square root of 2/2. You hanging in there? Well, guess what? All the 45 family are going to be the same, just what's going to change is negative and positive. Down in this quadrant, they're both going to be what? Negative, so it's going to be negative square root of 2/2 and negative square root of 2/2. Which one's going to be negative down here? No, the x is going to be positive down here, the y. So the x is positive square root, and the y is negative. You see why I was going over the hypotenuse of 1 with those two special rights. How we doing? What did we do next yesterday? Did we do 30? I thought we did 30. I'm going to do 30. Is that all right with everybody? Okay. So that was the 45, which we got in. Now we're going to do the 30 family. Remember reference angle. Looks like I lost my point on a couple of these. Let's clean that up because those points, we want those to stay on there. All right. 30. 150.
What?
Yep. 210 and perfect bowling game. That is not correct. How about a little over that? 330. Okay, radian measurement, 30 degree. Let's say it out loud together. 30 degree is pi/6. 150. 5pi/6. 210. 7pi/6. And finally 330. 11pi/6. Almost a complete 2pi. 12pi/6 would be 2pi. gonna use a different triangle this time, but what is the length of that? Again, that length is 1. Okay? So this is your 30. Across from the 30 is 1/2. Across from the 60 is the square root of 3 over 2. So my x is this square root of 3 over 2, and my y is 1/2. Now here's the cool part. Once you get that one, all the families, all the 30 family are all going to be the same except for negative and positive. Okay? So let's jump over here to 150. Here my x is negative square root of 3. My y is positive, right? At 210, I still have negative square root of 3 over 2, but it's negative half also. Over here at 330, my x is positive square root of 3 over 2, and my x is, my x is positive, my y is negative. How we doing? Still okay? What are we down to? The 60. Now the good news with the 60 is they're just like the rest. They're going to be all kind of the same. So we got 60 here. We got 120 here. We're looking at 240 here. And finally here, what are we looking at? 300. There's my perfect bowling game. Okay. What's the distance of this radius? 1. What's changed? Well, this is the 30. Now my x is 1/2, and my y value is square root of 3 over 2. So from the 30 to 60, all we're doing is changing the x and the y, right? Okay, so I am going to have my x at 1/2, my y square root of 3 over 2. Here my x is negative half, my y square root of 3 over 2. Down here in quadrant 3, they both are going to be what? Both going to be negative. And we're going to finish up over here in quadrant 4 with my x being positive and my y being negative. And there you have a wonderful unit circle. That, my friends, is a thing of beauty right there. Or a thing of torture, depends on what you think about it. Might want to jot in here, what's up here? They're both positive, aren't they? Right? In that quadrant, both positive, it's always no. Down here, they're both what? Both negative down here, okay? Up here, we're negative, positive. And down here, we're positive, negative. Now, last thing about this is your trig values, okay? Looking for a bright color to stand out. I guess we'll go with purple. Your cosine of any angle, excuse me, let's go back. I'm going to go sine. Your sine of any of these angles is equal to what? The y value over the radius. Well, what's the radius? 1. That makes it real simple. So the sine of any of these angles is just your y value. That's nice, isn't it? Because it's over 1. What's the cosine than of any of these angles? It's your x value, because it's over 1. What's your tangent of any of these 16 angles? It'll be your y value over your x value. So what am I going to ask you on some assessment? Because that's what you really want to know, right? I'm going to ask you to find the 6 trig values of any of these given 16 angles. And of course, the question is, will I be able to have my paper plate? And the answer will be no. And the next question is, decimals will be wrong. Now, if you YouTube this, there's a million of them out there, okay? I'm taping right now. Taping. I'm videoing this one right now, so you can watch this one. I'm gonna post it. You need to memorize this. I say no. You have to have a working knowledge of it, but I don't think you need to memorize it. The more you write it down, the better. All right, you ready? Let's try. Excuse me. We'll make one easy. All right, we'll do an easy one. Let's do pi over 4. Let's find all 6 trig values of pi over 4. So out there right now, you might think, oh my gosh, where's pi over 4? But what is pi over 4 in degrees? It's always helpful to put it back in degrees, that way you can see. It is what? Okay. I'm going to draw a circle. And this is how I would attack most of them myself. I know this is pi over 4, or 45-degree angle. Okay? As soon as I see it's the 45 family, I know it's going to be square root of 2 over 2, and square root of 2 over 2 for my x and y, right? There's my x, there's my y. Well, I'm up here in this quadrant, so I know they're both positive, right? Does that make sense to everybody? I know the more you work on it, the better you'll feel about that. That way I don't have to memorize it. What do I need to know? I need to know that if it's a 45 family, both legs are going to be what? Square root of 2 over 2, right? I know if it's a 30-60, across from the 30 is going to be the half. Across from the 60 is going to be square root of 3 over 2. That's what I need to know. All right. Now the good part is it's a unit circle, so the hypotenuse is 1. So my sine of pi over 4 is equal to my y value, which is what? Square root of 2 over 2. That's it. What's my cosine of pi over 4? Square root of 2 over 2. That's my x. How are we doing? We hanging in there? Sine, cosine, my tangent of pi over 4 is what? Square root of 2 over 2 divided by the square root of 2 over 2. Now, that's not brain surgery. It's the same thing divided by the same thing, so it ends up being what? 1. And those are all positive, right? So there's your sine, cosine, tangent of the 45. So I'm going cosecant, secant, and cotangent, and we'll put 45 this time. We use pi over 2, the other one. Whoop, not 54. What the heck? A little dyslexia there going. All right. Well, we got some work to do. We're going to invert that, so it's going to be what? 2 over the square root of 2, right? Now we'll rationalize. So we're going to have 2 square roots of 2 over 2. So it really just simplifies to what? Square root of 2. Well, folks, isn't this one going to be the exact same thing? The secant. So I'm not going to go through all that. I know it's the square root of 2. What's 1? We're going to invert 1 over 1, which would just still be 1. trig values over 45. Now, the only angles I'm gonna give you are those 16. I'm not gonna give you any others. Does that make sense? I'm gonna do 2 more. Let's do 2 more, and then we'll be done, and you can try a couple. The homework tonight just asked for singles. I'm not, I wanna do all 6 in the practice. That would be. All right, ready? 150 degrees, which would be what in radian measurement? Anyone? 150 degrees, anybody? 5 pi over 6. Draw out your circle, see if you can figure out what your x and y values are. And if you feel confident about it, move forward or check your plate if you want. I would try to get in the habit, if you need to check your plate here at the beginning, do so. But you gotta start not thinking about it. You gotta start kind of drawing it out and getting your angles. So we're looking at $1.50, which puts us right over here. See if you can get your x and y there.
Thank you, sir.
Right triangle across from the 30. There's your 30. Across from the 30 is 1/2. Across from the 60, square root of 3 over 2. Of course, that is negative. So my x here, this is for 150. My x is negative square root of 3 over 2, and my y is 1/2. 150 or 5 pi over 6. You might need to rationalize some, so see how far you can get with sine, cosine, tangent. Just try to get sine, cosine, tangent. You can stop there, and then, or if you want to keep going, we're going to do all 6, but so sine of 5 pi over 6, cosine of 5 pi over 6, tangent of 5 pi over 6. So sine is my y value. My y value here is 1/2, isn't it? My cosine is my x value. My x value is negative square root of 3 over 2. My tangent is going to be my y value, which is 1/2 over negative square root of 3 over 2. Now here's where we got to do a little work. A fraction divided by a fraction, so we're going to invert it and multiply. So that's going to be 2 over the square root of 3. It's still negative. That simplifies to negative 1 over the square root of 3, which is our answer, but we're going to rationalize it. And in fact, we're going to end up with negative square root of 3 over 3 as your tangent of 5 pi over 6. Hanging in there, my friends. I hope you are. I can see all of you are digging in. I appreciate it. It's not the easiest, but it's not undoable either. So we got sine, cosine, tangent. So now let's go with our cosecant, secant, and cotangent. Of course, is a 150-degree angle. By now we know we're going to invert these, so that would be 1/2. So that's going to end up being 2. We're going to have a little work here because we're going to end up with negative 2 over the square root of 3. We'll need to rationalize that, and we end up with negative 2 square roots of 3 over 3. Negative 2 square roots of 3 over 3. 150 cotangent. I'm gonna go back to here. I know you see me, I did that work down there. It is just like we did earlier when we were finding some of these. Go back to right before you rationalize, because then we can just invert this, so it's gonna be negative square root of 3 over 1, but we won't write it over 1. So we did a 45 family, right? We did a 30 family. Well, the 60 family is going to be very similar just because it's X and Y are just switching, right? I want to do one more and then we'll be done, and that is one of the 90 family. Is everybody good here, note takers? Everybody got what they need? Okay, let's do one more. Let's make it 3 pi over 2. 3 pi over 2. Degree measurement, 3 pi over 2, anyone? 3 pi over 2 is 270. Okay, puts this our angle right down here. This is the point we're interested in. What is my x at that point? My x is what? My x is 0, my y is -1. Does that make sense to everybody? Okay, now, sometimes we're gonna have some undefined ones. If you divide by 0, we're gonna have undefined trig values, and that's gonna happen in the 90s family. There will be some undefined trig values in the 90s family. All right, so we're doing 270, 3 pi. The sine of 3 pi over 2 is my y value here. What's my y value here? Yes, right, -1. What's my cosine of 3 pi over 2? It is my x value, which is 0. And my tangent of 3 pi over 2. It is what? My y value, which is what? -1 over 0. Well, we can't divide by 0, so this guy is undefined. There's no tangent for 3 pi over 2. We all right? Sine, cosine, tangent, cosecant, secant, and cotangent of 270. All right, so that'd be -1 over -1, with -1 over 1, which would be still -1, right? Secant. Secant's gonna be a little different, okay? It's gonna end up being undefined. Because we're dividing by 0 there when we invert d1 over 2. Cotangent. This one's a little bit different too. It's gonna be 0 over -1, which is 0. Be careful, that's not undefined. Where's the only spot we can't have zeros in the denominator? If it's in the numerator, we divide by -1, that's 0. All right, you guys are great. You guys are very involved, hanging in there. Note taker's good on this page. Okay, I got a small assignment for you. As soon as I get there. Got lots of circles up here. Where'd it go? There you go. It's just asking for singles. Okay? The homework asks for singles, not all 6. If it was asked for all 6, that would be a ridiculous amount of work I gave you, but I'm not. They're asking like just the sine or just the cosine. You might want to practice maybe one getting all 6, but submit that. Thank you very much.